Hello, welcome to Algebra 1 Home Learning Lesson 1 with Miss Barrett. Hopefully by the end of this lesson, you'll be able to factor out the greatest common factor. We have been learning about quadratics for the past couple of weeks, and we're going to move forward with this idea, talking about factoring polynomials, and then we'll go forward and talk about different strategies to factor quadratics. Activity 1 is the notes, which was given in the email. Activity 2 is guided practice, also in the notes. And then I will go over 2 individual practice problems. And the hope is that you guys will complete the rest of the practice problems at home. And then we can go over the answers in the next lesson. Okay, so now let's define what a greatest common factor is. A greatest common factor is the largest factor two numbers or it could be 3 or 4 or 5 or 6 have in common. So it's basically the largest factor that more than one number have in common. Okay. So when you're factoring the GCF out, the GCF goes outside of the parentheses. And you'll see this as we go along. To check your factoring and make sure your factoring is correct, you want to multiply the polynomials. And again, you'll see this as we go along. So just remember these 3 things. The first 2 examples we're going to look at is dividing out the GCF using prime factorization. Now let's review what a prime number is. A prime number is a number that can only be divided evenly by the number 1 and itself. So example 2, 3, 5, 7, 11, 13, 17, and 23. There are more numbers that are prime numbers. Okay, so the number 2 can only be divided by the number 2, because 2 divided by 2 is 1, and 1. 2 divided by 1 is 2. 3 and 5 and 7, 11, 13, 17, and 23 are also the same. They can only be divided by themselves. For example, 17 divided by 17 is 1. And the number 1, 17 divided by 1 is 17. Those are the only 2 numbers that 17 can be divided by evenly. Okay. So when we talk about prime factorization, we're talking about using these prime numbers to identify the factors of any number. So for example, I did the prime factorization of 12. Okay. I try to use the biggest prime. What's the biggest prime number I can think of that can divide 12? Well, that's 3. None of these other numbers can divide into 12 evenly. So 3 times 4 is 12. So these are the factor pairs, 3 times 4. Now I cannot break down 3 because 3 is a factor, but I can break down 4. The factors of 4 are 2 and 2. So basically each level of this, you're going to break down the numbers that you can. Eventually, you're going to end up with all primes. 3, 2, and 2 are all primes. That's why they're underlined. Once you're ending up with the primes, then you're done because you cannot divide these numbers anymore. These don't have any other factors other than 1 in itself. Okay. So now I have my prime factorization of 12. Let's try 15. The largest prime number that goes into 15 is 5. So 5 would be my prime. 5 times 3 is 15. And fortunately, this is the quick prime factorization because 5 and 3 are both prime numbers. Okay. Last but not least, the number 44. The number 44 can be divided by 11. That's the largest prime number that can go into 44. 11 times 4 is 44. 4 can be broken down into 2 times 2. And now I have all of my prime numbers. So again, we start with the largest prime we can find. Find the factor pair or the multiplication pair for that prime number. And if you can break down something again, this number could have been 6, it could have been 8, it could have been, well, not for 44, but let's just say we were doing 88. This number could have been 8. You would break it down to 4 into 2, and then break down 4 again into 2 and a 2. All right, now let's do that for these polynomials. Here we have 6a plus 9. Now, do realize that this a is also part of this 6. Okay, so when we're thinking about what do they have in common, we also have to think about the variable a, or in other examples, it's going to be x or t or whatever the variable is. We have to consider those when we're thinking about what they have in common. So here we have 6a. Well, this 9 does not have an a, so therefore that's not going to be part of the greatest common factor. So we have to do our prime factorization of the number 6 and the number 9. Okay, start with the largest factor, prime factor of 6, which is 3. And the factor pair is 2, because 3 times 2 is 6. So we have our 2 primes. 9 is very similar. The largest prime factor of 9 is 3. 3 times 3 is 9. We have our 2 prime factors. Now let's look here. What number do they both have in common? They both have 3 in common. So 3 is going to be the GCF, the greatest common factor. So I'm going to put my 3 on the outside of my parentheses. And when I divide 6a by 3 and 9 by 3, when I take it out, I'm left with 2a, because 6a divided by 3 is 2a. And I'm left with 3, because 9 divided by 3 is 3. Again, I put my parentheses on the outside, GCF on the outside, and I put in the parentheses what I have left when I divide my numbers or my terms by my GCF. And how I check this is by multiplying this polynomial. Okay. So 3 times 2a plus 3. Okay. Use my humps. 3 times 2a is 6a. And 3 times 3 is positive 9. And if you see here, we ended up back with what we had originally. That's how we know that it's correct. Let's do example number 2. 12x squared and 8x. So we have 12x squared and negative 8x. Notice that I brought the variable with me, as well as whatever the exponent goes with the variable, and the signs, because that matters as well. So here, for 12x squared, I can have my largest factor, prime factor, it would be 3x, which could be multiplied by 4x. Because 3x times 4x is 12x squared. And this could be simplified into 2x times 2. Because 2x times 2 is 4x. Now I have all my primes. Now this negative 8x can be simplified into, my largest prime would be 2. And we can do it two ways. You can do 2x times 4. You can do negative 2x times 4, or you can do negative 2 times 4x, or you can do 2 times negative 4x. Now, I wouldn't get held up on the signs, okay? And if this way confuses you, I'll show you another way. So, but for right now, let's just say that we can break this 4 into 2 times 2. So now I have all my primes. Okay. If you see here, they have a 4 in common. The biggest factor they have is 4. But if you look here, you ask yourself, well, how many x's do they have in common? If you want to ignore this part, let's say, how many x's do they have in common just by looking at it? Well, each of these, 12x squared and then negative 8x, has 1x. So we're going to say that they have 1x in common. And they also have a 4 in common. So the GCF here is going to be 4x. Okay. And that's just by looking at it. We can see here that they have at least 1x in common. Okay. So if 4x is my GCF, I'm going to divide both of these terms by 4x. When I divide 12x squared by 4x, we have to use our exponent rules. X squared divided by x, you're basically subtracting the exponent. So 2 minus 1 will give us, and then 12 divided by 4 will give us 3x, because x squared divided by x is just x. So I'm saying x2 minus x1. 2 minus 1 is 1. And then negative 8x divided by 4x will give us negative 2, because negative 8 divided by 4 is negative 2. X to the first power divided by x to the first power is like saying 1 minus 1, which is 0. So there's no x there. Okay. So now I have, this is my answer. If I was to factor this, this would be my answer. Just like this was my answer. And I have to check it. So 4x times 3x minus 2 I'm multiplying them using my humps. 4x times 3x is 12x squared. 4x times negative 2 is negative 8x. And that brought me right back to my original, so I know it's right. So I'm going to do the same thing. I know this says dividing out the GCF, but this is pretty much the same thing as we did before. Okay. So I'm going to use my prime factorization. I have 3x squared minus 15x. I'm not going to do the complicated prime factorization for the variables, because really you can just look and see, well, this has 2 x's because x squared is the same as saying x times x. So that's 2 x's, and this one has 1 x. So we know they at least have 1 x in common. Okay. All right, so the prime factorization of 3, well, 3 is a prime number, so it's just going to be 3 in itself, and 1. Then 15 has the prime factorization of 3 and 5, or 5 and 3, however you want to write it. They both have, these are both primes, these are both primes. Okay. Now, as you can see, the largest number that they have in common is 3. Okay, but they also share an x. Don't forget that. So 3x is going to be the GCF. So I'm going to divide both of these by 3x. 3x squared divided by 3x. Well, 3 divided by 3 is 1. And x squared divided by x, again, it's like saying 2 minus 1. So it's going to be 1x. You don't have to write the 1 if you don't want to. Negative 15x divided by 3x becomes negative 15 divided by 3 is negative 5. X divided by x is 0. X to the 0 power, which is just 1. So I'm going to have that left, and then remember my 3x is in the front. Sorry about that. So your GCF goes on the outside. Whatever's left goes in the inside. Let's check it by multiplying. We have 3x times 1x minus 5. 3x times 1x is 3x squared. 3x times negative 5 is negative 15x. Bam, right back to where we started. Now we have a trinomial. So we have 3 terms. One is 2x squared. The second one is negative 4x. The third one is 6. We have to do our factorization of all of those numbers. So here, now you might be able to just see, look at the numbers and tell that here 2 is going to be the largest factor. Okay, because it's just 2, it's not 2x, because this has 2 x's, this has 1 x, and this has no x's. So they don't have any x's in common. In order for them to have at least 1 x in common, this 6 would have to have an x, but it does not. So we can't say they have an x in common because this 6 does not have an x. Okay. All right, so now we have 2, 4, and 6. We have to do our prime factorization of all of those. Okay. All right, now the prime factor, largest prime factor is 2 times 1 equals 2. Now we have both our primes. Largest prime factor of 4 is 2 times 2 equals 4. Therefore, we have our 2 primes. And then the largest prime factor of 6 is 3. And 3 times 2 is 6. And we're done with our primes. Okay. As you can see here, the largest number they all have in common is 2. So 2 is going to be our largest common factor here, or greatest common factor. So I'm going to put the divide by 2 here on everything. Put the 2 on the outside of parentheses, and let's see what I have left. 2x squared divided by 2. 2 divided by 2 is 1. I don't have anything dividing the x squared, so x squared is all that's left. Negative 4x divided by 2, or negative 4 divided by 2 is negative 2. I don't have anything dividing the x, so x is what's left. So it's negative 2x. And last but not least, positive 6 divided by 2 is positive 3. So basically, you divided everything in this original polynomial by the GCF to figure out what you have left. Put your GCF on the outside of parentheses. What you have left when you divide goes in the inside of parentheses. And let's check it by multiplying our polynomial. Two times x squared is 2x squared. 2 times negative 2x is negative 4x. 2 times 3 is positive 6. And we're right back where we started. So we know that our factorization was correct. All right, now some situations make it tricky. There are some tricky situations. So now you have 10x squared minus 15x plus 5. Why this is tricky is because it looks different than what we're used to. We're used to the numbers ascending as they go from left to right. So usually it would be 5x squared minus 10x plus 15 or minus 15. But here the numbers descend, which is okay. It's all the same. So we still have to find out prime factorization of 5, 10, and 15. Okay. For 5, the largest prime number is 5, and 5 times 1 is 5. We have our 2 primes. For 10, the largest prime factor is 5. 5 times 2 is 5. Is 10. And then for 15, the largest prime factor is 5. And then 5 times 3 is 15. So therefore, as we see here, the largest number they have in common is 5. They don't have any x's in common. This has 2 x's. This has 1 x, but this has no x's. The 5 has no x's. Therefore, they do not have any variables in common. So we're just going to say 5 is our GCF. Let's divide it out. Put it on the outside of parentheses. Decide what's left. 10x squared divided by 5. 10 divided by 5 is 2. The x squared is not being divided. You bring it down. Negative 15x divided by 5 is negative 15 divided by 5 is negative 3. The x is not being divided by any other variable. So you just bring down that x. And then 5 divided by 5 is 1. Positive 1. Okay. And we're going to check it. Five times 2x squared minus 3x plus 1. 5 times 2x squared is 10x squared. 5 times negative 3x is negative 15x. And then 5 times 1 is 5. Back to where we started. So we know it's right. Okay. Now this one is super tricky. And it's only tricky because there's so many variables. Okay? There's so many variables. So let's look. First, let's do our prime factorization of our numbers. So we have the number 2, the number 8, and the number 4. Okay. 2, 8, and 4. Prime factorization of 2 is 2 and 1. Prime factorization of 8 is 2 and 4. And then also 2 and 2. Right? 2 times 4 is 8. 4 can be broken down into 2 times 2. We have all our primes. And then last but not least, 4. Prime factorization is 2 times 2. We have our 2 primes. The largest number they have in common is 2. Okay. But let's look at our variables. Okay. Let's start with the x. So you want to break it down. You want to start with one variable at a time. So this 2x cubed has 3 x's. This 8x squared has 2 x's. This negative 4x has 1 x. So this has 3 x's, 2 x's, and 1 x's. They at least have one x in common. Each of them has at least one x. Therefore, this is going to be 2x. And we have to divide all of our terms by the same GCF. Okay. Now let's look at our y's. Again, we're breaking it down. This has 2 y's, this has 1 y, this is 1 y. So they also at least each have 1 y in common. So my GCF here is 2xy. That's what we're going to put on the outside. What's left? Well, 2 divided by 2 is 1. X cubed divided by x is like saying 3 minus 1, which is x squared. Remembering our exponent rules. Y squared divided by y is like saying 2 minus 1, which is just 1. So it's just 1y. Plus 8 divided by 2 is 4. X squared divided by x is 2 minus 1, which is just 1x. Y divided by y is like saying 1 minus 1, which is 0. So there's no y's here. Okay. Negative 4 divided by 2 is negative 2. X divided by x is 1 minus 1, which is 0. And then y divided by y is 1 minus 1, which is 0. So there's no x's or y's for this last term because they all cancel out. Okay. So I'm left with 2xy times 1x squared y plus 4x minus 2. Let's check and make sure that's correct. So then that's going to give me 2xy times 1x squared y. So 2 times 1 is 2. And remember, you can only multiply the like terms, guys, here. So this variable x can only be multiplied by this variable x. Okay. So x times x squared is like adding, remember the exponent rules? X to the first power times x to the second power, like saying x 1 time plus 3. Which is x cubed. Okay, y times y is like saying y to the first power times y to the first power, which is 1 plus 1, which is y squared. Okay. 2xy times 4x. Well, 4 times 2 is 8. Okay. And then only thing I can multiply here is the x times the x, which is like 1 plus 1, which is x squared. And then y, you can say y times 1 because you're multiplying, so it'd just be y. And then 2 times negative 2 is negative 4. There's a silent 1 right here, so I'm sorry, invisible 1. So then you can say x times y times 1 is xy. And again, we're back to where we started. Okay. So I think the clue here, or the takeaway here, is that whenever you're doing your prime factorization of your numbers, right, you choose the largest prime they have, the largest number they have in common of that factorization. You also have to think about your variables. So for each term, you have to count how many of each variable they have, therefore finding how many they have in common. If they have 1 in common, you just put down 1 as your GCF, 1x or 1y. If they have more than 1, then however many they have, you have to write that down as your GCF. Okay. Now, let's do a couple practice problems together. The rest of these practice problems, I do intend on you all doing it by yourself. Okay. All right, let's look at one of the harder ones. Let's look here at number 7, and we'll do this together. All right. So here we have g squared h minus 7 gh cubed plus 14h squared. Now, in front of this G, there's kind of an invisible 1. You don't need to write it, but if it helps you, write it. So we have 3 numbers. We have 1, 7, and 14. Of course, the prime factorization of 1 is 1 and 1. Prime factorization of 7 is 7 and 1. And the prime factorization of 14 is 7 and 2, which are all primes. Okay. The largest number they have in common is 1, or they always have 1 in common. You can say 14 also has 14 and 1. So that's the largest factorization prime number they have in common is 1. But we don't have to divide by 1. That's fine. We can do 1. Now we have to figure out what are the variables they have in common. So each of these, so G squared, G, and this one has no G. Therefore, they do not have any G's in common. So G cannot be part of the GCF. Okay. They do, however, each have at least one H. This has one H, this has 3 H's, this has 2 H's. Okay. So we can then say they at least have one H in common. Okay. So then our GCF is basically just H, or 1H. And we have to figure out what's left. So G squared H divided by 1H. The G's are not divided by anything, so you still have your G squared. H divided by H is 0, or H to the 0 power, which is 1. So you don't have to write H there. Negative 7 divided by 1 is negative 7. The G's don't get divided, so you just bring it down. And then H cubed divided by H is like saying 3 minus 1, which is H squared. 14H squared divided by 1H. The 14 divided by 1 is just positive 14. And then H squared divided by H is like saying 2 minus 1, which is just H. Okay. And then let's check it. 1H times G squared minus 7GH squared plus 14H. That's going to give me 1 G squared H minus 7 G, H times H squared is H cubed, times 1 times 14 is 14 H squared. H times H is H squared, which is where we began. Okay. And then let's do this one. Let's do number 2. I have 12a squared plus 16a minus 4. So I have 12, 16, and 4. 12 would be 3 times 4, which can be broken down into 2 times 2. 16 would be, what's the prime number? 2 times 8. And then 8 can be broken down into 4 times 2, which can be broken down into 2 times 2. Again, you want to end up with all primes. And then 4 can be broken down into 2 times 2. So it's clear that the largest number, or 4 and 1, we have 4 and 1, and then 2 times 2. So if we look here, the largest number they have in common are 4. Okay. Now let's check to see if they have any variables in common. 12a squared, 16a, and negative 4. Okay, this does not have any a's, so therefore they have no a's in common. So the only factor is the GCF would have to be 4. 12a squared divided by 4 Put 4 on the outsides of the GCF. That gives us 3a squared left. 16a divided by 4, that gives us 4a left because the a is not being divided by anything. And then negative 4 divided by 4 would give us negative 1. We can check it by multiplying it in. 4 times 3a squared plus 4a minus 1. 4 times 3a squared is 12a squared. 4 times 4a is 16a. And then 4 times negative 1 is negative 4, which is right where we began. Okay. So now your job is to do this, the rest of these at home on your own. Okay. And then when we come back on the next lesson, we'll look at the answers.